This is our first question from exercise number 5.4. If two coins are tossed, find the probability of the following event: getting at least one head and getting no head. So in this question we have we need to find out probability of two events. One is getting at least one head and the other event is getting no head. So in order to calculate the probability, first we need sample space and number of sample points. So here we're going to toss two coins together. So first I'll write my sample space. If two coins are tossed, then sample space would be head head, head tail, or tail head, or tail tail. So this could be our sample space and number of sample point will be 4. After that we will take first event, getting at least one head. So in this we need to assume a name for this particular event, because we know in order to write the event in the form of set we need a name of the set. So here getting at least one head, question says find the probability of getting at least one head. So here I'll consider, for first, let A be the event of getting at least one head. So this way A will become, A is name of this particular event. So here I'll take A. Question says getting at least one head, minimum one head. We can have more than one head. So we can take HH where we have at least one head. We can take H tail and HTH. We cannot take this tail because this particular term has two tail, no head is there. So number of A is 3. Now we need to calculate probability of this event. So we will find out probability of A also. So probability, P stands for probability. Probability of event A. Event A is what? Getting at least one head. So probability of A is equals to number of A upon number of sample space. So this is our formula to find out probability of any event in any question or in any random experiment. So number of A we have 3 and number of sample space 4. So this is our probability of this particular event. Getting no head. Second one is getting no head. So here we will consider a name for this event. Let B be the event of getting no head. Means we don't want head, only tail. So B will become tail tail. So number of B 1. And probability we need to calculate. So probability of B is equals to number of A upon number of sample space. Yes. So number of A number of B upon number of sample space. Number of B is 1 and number of sample space will remain as 4. So this is a probability of getting only tail or no head, and 3 by 4 is the probability of getting at least one head. So this way we can find out probability, and this is same formula for all the question, that probability of any particular event is equals to number of that event upon number of sample space. There are 15 tickets in a box, each bearing one of the number from 1 to 15. So each ticket has one number on the ticket. That is, numbers are 1, 2, 3, 4, 5 up to 15. One ticket is drawn at random from the box. So we picked one ticket from the box. Find the probability of the event that the ticket drawn. First probability we need to find out shows an even number. So probability of getting a ticket having bearing even number. So first we will write down the sample space. Sample space, we have 15 tickets, each ticket bearing one number from 1 to 15. So sample space is 1. One stands for the ticket bearing number 1. Then 2 is the ticket bearing number 2. 3 is the ticket bearing number 3. Same way we have 15 such ticket, so up to 50. So this way we have number of sample space. So we have number 15 tickets. So number of sample space would be 15. Then come to this event, first event, whose probability we need to calculate, shows an even number. So we need to find out probability where the ticket shows an even number, and one ticket is picked randomly. So let A be the event of getting a ticket shows an even number. Now, so 2, 4, 6, 8, 10, 12, 14. So these are the tickets which has which are bearing even number. So number of A, 2, 4, 6 and 7. We have 7 such tickets which are bearing even number. So probability of those ticket, probability of A is number of A upon number of sample space. This is a formula to find the probability. Number of A is 7 and probability is 15. So this is the probability of getting a ticket bearing an even number. Same way we can find out second one, probability of this event shows a number which is multiple of 5. Multiple of 5 means 5, 10, 15. So we have 3 such numbers. So same way you will consider, let B be the event of getting a ticket shows multiple of 5. So B will have all the multiple of 5 in the sample space, that is 5, 10 and 15. These are 3. multiple of 5 in the sample space. Number of B is 3 and probability of B is number of B upon number of sample space. So number of B is 3 and number of sample space is 15. So 1 by 5 is your probability. So these are two probabilities, 7 by 15 and 1 by 5. 7 by 15 where the ticket is even bearing even number, and the probability of B where the tickets. So these are two probabilities, probability of A and B, and this way you can find out. Second probability shows the number which is multiple of 5. So this is your complete solution for this question.